Hello everybody, it is time for us to take a look at the lesson 2-3 worksheet, which I think is a pretty fun section, not too bad in the grand scheme of things, and no proofs on this worksheet, so it should go pretty quick. Starting here with number 11. Marisol claims that each pair of remote interior angles in a triangle has two exterior angles. Do you agree? Draw a diagram to support your answer. So let's draw a triangle. Could be any triangle here. And let's see, each pair of remote interior angles has two exterior angles. So maybe these could be the interior angles that we're talking about. And if there are two exterior angles, there's one of the exterior angles. We'll call that angle 3. But there's another exterior angle that I can make if instead I extend this line right here. If I extend this line, that becomes angle 4. Angle 3 and 4 are both exterior angles for remote interior angles 1 and 2. Remember, remote means the other two interior angles in a triangle. So we can say yes, angle 1 and angle 2 are remote interior angles for both angle 3 and angle 4. There are two exterior angles there, and everywhere else as well. Number 12, a student was asked to find the value of x. What error did the student make? So they said by the linear pairs theorem, w plus 56 equals 180, so w equals 124. By the triangle exterior angle theorem, w is equal to x plus 31, or 124 equals x plus 31, so x equals 93. However, 31 and x are not the two remote interior angles of this triangle. 31 isn't that whole angle. If we're looking at the triangle, the two remote interior angles for w are x and 31 plus 44, or 75. So she should have said, w, the exterior angle, is equal to the sum of the two remote interior angles, x plus 75, which is 44 plus 31. And that means x equals 49 when we solve it all out. All right. Number 14, what are the values of x, y, and z? Use theorems to justify each answer. Well, let's take a look. We can look at angle x here, and we see that there is a line, and these three angles together make up 180. All right, so that's one way we could look at it. Then we can also see that x is actually, we'll come back to x. I'm sorry. I wrote these in order, but I actually solved them out of order. I said my first thing was that y is equal to 66 degrees, right? Y is equal to 66 degrees by vertical angles. Okay? Then I know that z, do I get z next? Now I'm questioning myself. I'm second guessing myself. That's great. Great, great, great. Well, if I know that 74, let's see. I should know better than this, shouldn't I? This is embarrassing. Okay, here we go. This is 66 degrees because of alternate interior angles, right? This angle and this angle are alternate interior angles across a pair of parallel lines. So then I take 180 minus 74 minus 66, and I get x right there. So x is equal to 40 by alternate interior angles and adding to 180. Right, so if we know x is 40, then z is really easy because we can say, all right, z is equal to 66 plus 40 because z is the exterior angle. 40 and 66 are the remote interior angles of this triangle, which means z is equal to 106. So z equals 106 by the triangle exterior angles theorem. Exterior angles theorem. All right, sorry about that, folks. Number 15, write and solve an equation to find the value of x. What is the measure of each labeled angle? Well, one way we could think about this is we know that the sum of the angles in a triangle is 180. So we could write x plus 3x plus 2x equals 180, although there's a lot of ways to solve this. So that's 6x equals 180, divide by 6, and we get x is equal to 30. So that's part of our answer. So let's find the value of x. We did that. And what is the measure of each labeled angle? Well, this is 30 times 5, so this is 150. This is 30. This is 30 times 3, or 90. And 30 times 2, or 60. And we can just write those in there. Number 19, find x and y. Well, y is pretty easy because we know that the angles in a triangle add up to 180. So we can do 180 minus 39 minus 91, and that's going to give us angle y. And so that'll be 50 equals y. So there's 50. Then if we want to find x, there are a few different ways to do this. I did it by looking at the entire triangle. So I know this is 50 for this corner. This corner is 71. This corner is 39 plus x. This whole angle is this angle of the triangle. So I can say 180 minus 71 minus 50 minus 39 is going to give us what's left over for angle x. And that is going to be 20 equals angle x. Number 22, for finding x here, we have the exterior angle theorem where 119 is equal to the sum of the two remote interior angles that we have there. So 119 is equal to x plus 46. This is a simple one. So x is equal to 73. Number 28, a pennant is in the shape of an isosceles triangle. One leg of the triangle is fastened to a stick. The other leg forms an 84-degree angle with, or the stick forms an 84-degree angle, rather, with the other leg. What is the measure of each remote interior angle? So this one took me forever to figure out how the book wanted me to draw it. So I'll draw a picture of what it really means here. So here's the stick of just like the flagpole. And then here's the pennant. Maybe something like that. And it's an isosceles triangle with these two sides being the same shape, or being the same length. It says one of the legs is fastened to the stick, the other one forms an 84-degree angle. So this is actually kind of out of scale here, but this is the angle that is meant to be 84 degrees. And if this angle is meant to be 84 degrees, when it says what is the measure of each remote interior angle in the triangle, that would be, of course, the other two interior angles in the triangle. And those would be 180 minus 84 which is going to be, wait. Nope, messed this one up again. Hold on a minute. That's not that picture. Let's try this one. This one gets me every single time that I teach it. All right, we've got our stick. We've got our 84-degree angle coming up here. And we have our isosceles triangle, like that. Here is the 84-degree angle. And if we're looking for the measure of each remote interior angle, we're looking at this angle and this angle. There we go. So this angle and this angle are the same because we have an isosceles triangle. So we know those base angles are going to have to be the same thing. And that means that we know that 84 is equal to x plus x. They have to be the same. So really we're just dividing by 2. And we're going to say x equals 42. So each of these two angles right here in the corners are 42 and 42. So that's our answer, is 42 and 42. That's not a very good question. If you did not understand this because you didn't understand how the drawing should look, that's fine. Don't worry about it at all. Number 29, Pilar is making a replacement set of sails for a sailboat. What equation can Pilar use that relates the values of W and X? So W and X are two of the angles in a right triangle where the other angle is 90. So I can say, well, if all of my angles equal 180, then W plus X must equal just 90 because the rest of the triangle is a right angle. For B, what equation can Pilar use that relates the values of Y and Z? We see that Z is an exterior angle of that triangle. So we can say that Z is equal to the two remote interior angles added together. So we can say that Z is equal to 90 plus angle Y. There are other ways to make those equations as well, but that's just one that we could do. Number 31, what is the value of X? Okay, so for the value of X, we say, well, we know some things about this triangle, but not everything. But what we can find out is what is this angle right here, because that's going to help us out. So I can do 180 minus 119. Right? And 180 minus 119 is going to be 61. So this angle right here is 61 degrees. So to find the value of X, I can take 180 minus 70 minus 61. And I can find that A is going to be 49 degrees. For B, what is the value of Y? Well, if this is 49, and I know that this angle right here is 119 and 28, I could use this piece of the chair just as one triangle. And I could say, to find the value of Y, I can do 180 minus 28 minus 119, and that is going to be 33 degrees. And then C, the chair can lay farther back so that the 70-degree angle changes to an 86-degree angle. So this angle is going to change to an 86-degree angle. And X degrees, this one right here, changes to 36 degrees. How does this affect the 119-degree angle? Well, if we redraw this triangle and show what's going on there, let's see. This X is changing to, there we go. You'll see why I'm drawing it this way. X is changing to 36 degrees, and the 70-degree angle changes to 86 degrees. And we're looking at how this affects the 119-degree angle. Well, now that angle, which is the remote exterior, or the exterior angle of 36 and 86 as the remote interior angles, means that x is equal to, or the angle will now be equal to 36 plus 86, or 122 degrees. So this angle changes, right? This angle right here changes from 119 to 122 if these two changes are made to these two angles. Almost done here. What are the values of x, y, and z? Well, for x, I see that, again, it is the exterior angle of two remote interior angles here and here. So I can say that x is equal to 45 plus 66. So x is going to be equal to 111 degrees. Then we're looking for y. We can do this a few different ways. If I consider that y is one of the remote interior angles of 111 is the exterior angle, y is right here, and this is the other interior, remote interior angle, I can say that 111 that we just found is equal to y plus 45 plus 30, right? 45 plus 30 would be 75. So 111 equals y plus 75. Subtract 75 from each side. So y is going to be equal to 36. All right, so there's a 36. And then we have to look for angle z. All right, so angle z, how are we going to find that one out? We know that 119 is an exterior angle. 43 and z are the remote interior angles. So I can say 119 is equal to 43 plus z. And I can solve that really easily because that tells me then if we subtract 43 from both sides, that z is equal to 76. There are lots and lots and lots and lots and lots of ways to do this problem. I just showed you one way, okay? There's a lot of ways that you can use the triangle angle sum theorem instead of using all those exterior angles. You can do them in a different order. There's a ton of stuff that you can do. Ooh, that one became a trapezoid. Okay. So then down here, last one, what is the value of x? So in order to find this, we should be able to find the interior angles real quick, right? I know 127 plus this angle right here is 180. So I can do 180 minus 127, and I can find that this angle is 53 degrees. I can do similar things but different over here because I know these vertical angles are going to be the same. So that's going to be 49. And now I know that x is an exterior angle of these two remote interior angles. So x is equal to 53 plus 49, which means x is equal to 102 degrees, making C the correct answer to the question. All right, if you've got any questions whatsoever, don't hesitate to let me know. And hopefully this helped you out. Have a wonderful day.